Today we are going to introduce one topic in mathematics paper 2. That mathematics paper 2, it's having few topics, and of which if a learner can master all of them, that learner will do very well in paper 2. The topic that we're going to introduce today is analytical geometry, which is the second topic in mathematics. That topic, analytical geometry, has something like plus minus 30 marks, and then we start with statistics. Statistics has plus minus 20 marks. Then comes trigonometry, that has plus minus 50 marks, and then last but not least, Euclidean geometry, that has plus minus 50 marks. So if a learner can do well in statistics and do well in analytical geometry, especially learners that are struggling in mathematics, they can still pass, because out of 50 marks, if they can get more than 40, and in other topics they can scramble and get that 5 to make it 45, which is 30% of mathematics. So that learner can really pass mathematics. So as I said, today we are going to introduce analytical geometry. So when we talk about analytical or geometry, we have the analytical geometry and we also have Euclidean geometry. So this analytical geometry is the one that when we deal with it, we are dealing with it within a Cartesian plane, unlike the Euclidean geometry, which is just out in a space. But this one, it's specifically inside a Cartesian plane. We're dealing with coordinates to deal with this kind of geometry. Because when we talk about geometry, we talk about shapes, we talk about measurements, we talk about the properties of those shapes. So here, the basic thing or the basic knowledge that you need to acquire are the properties of all polygons, especially the triangles and quadrilaterals, because those ones, they are the ones that are examined at all times, and when you are examining on that, you need to know the properties of those polygons in order for you to answer the questions in analytical geometry. If we have time, I will show you how the analytical geometry that involves one of the polygons is presented in a metric paper, the final paper. So here, this is what we are going to take a look at, or this analytical geometry. It's all about the properties of polygons and also the properties of a circle. And then in there, what we're going to do today, we will take a look at the distance. We know that analytical geometry has to do with the distance, and then we are going to take a look at the midpoint. We are also going to take a look at the equation of straight line or line. The equation of a straight line. We are also going to take a look at the inclination of a line. Inclination of a line, which this one will give us also the angle of inclination. The inclination of a line will also give us the angle of inclination. We are also going to, maybe in another lesson, the equation of a circle. The equation of a circle. We will also touch on, because this is what matters most in analytical geometry, the properties of parallel lines, also the properties of perpendicular lines. So this, in short, what we are going to take a look at today. So then, when we look at this, this is how the analytical geometry is mainly based on the distance, which we are going to take a look at the formula. That distance is a formula whereby it's all about the square root of, you know, x2 minus x1 squared plus y2 minus y1 squared. So this equation gives us the distance of any straight line at any given time in a Cartesian plane. And then we have a midpoint. So when we talk about the midpoint, that one we now say x1 plus x2 over 2, and then will be y1 plus y2 over 2. Then the equation of a straight line, in most cases, is the one that it's y is equals to mx plus c. So in this one, the m is for the gradient, and then the gradient, that is where we talk about the inclination of a line. So that inclination of a line is the one that gives us a gradient, and then again we also have the c. The c is the constant value in that particular equation. So it can be presented in this way, or it can also be presented in this way, whereby we have y is equals to mx plus c, or y minus y1 is equals to m into x minus x1. So this, they give us the same thing, but this is the standard form. And then sometimes when they want you to find the inclination of a line, you just say here, like the gradient here, it's m is equals to y2 minus y1 over x2 minus x1. So that is where we get the inclination of a line. And then again we have the angle of inclination. That angle of inclination, it's where now we use the tan of an angle. It's equals to the gradient of that particular line. So this one is the equation of a gradient, and this one is the one that gives us the angle of inclination. Then, now with the angle of inclination, for example, if we have a Cartesian plane and we have a line like that, the angle of inclination, it's always on the top part of the x-axis and the right side of the line. So meaning that in this case, that angle of inclination will be there. But in another one, whereby now we have it like this. So now, again, is the top of x-axis and the right of the line. So meaning that that angle of inclination in this case, it will be here. So then in this, if it's like that, whereby that angle, when you are substituting it there, it gives you the acute angle, then you leave it like that. But the one that gives you, or the positive angle, so to say here, positive angle, you leave it like that. But in this case, in most cases, it will give you, or it will give you the negative angle. And then that negative angle, now you have to use that reduction formula for 180 degrees minus that particular angle. And then it will give you the obtuse angle of this particular one. And then now we also have the equation of a circle. So when we talk about the equation of a circle, it's that one that it comes in this way. It comes in this way where it's almost the same, or is the same as the theorem of Pythagoras, whereby now we have y squared plus x squared is equals to r squared. So that is the standard form of that equation of a circle. Or else we have y minus y1 squared plus x minus x1 squared is equals to, and then now, this one, it's PQ P, Q, and then here we can have that, the x squared, x1 squared, y2, y1 squared. So then that is how the equation of a circle may come in that particular matter or in that particular fashion. So then with a parallel lines are straight lines. So therefore the equation of any of those will fall in between these ones and also the perpendicular lines. And then what else we know about the parallel lines is that their gradient are equal, or their gradients are equal or the same. And then with the perpendicular lines, when you multiply their gradients, then it will always give you a -1. When you multiply the gradient of perpendicular lines, they will always give you a -1. So that, in a nutshell, the summary of analytical geometry. So that is how this is. So we will start with the distance, which we can also work hand in hand and like with the midpoint. The midpoint. So when it comes to a distance, for example, if we have a Cartesian plane and then we have a line. So this line, let's say here it's point A and here is point B. And then the coordinates of A, 2 and 1, and the coordinates of B, we have -2 and -3. So if we have that line, and then they say to you, calculate the distance. Calculate the distance of line AB. So then, what we have to do is we take that formula, which is AB, it's equals to the square root of x2 minus x1 squared, x2 minus x1 squared, plus y2 minus y1 squared. So that is the formula that we have. In this, if we can just say the B point is our second point and A is our first point. So the coordinates of B, then the coordinates are written in a way that the first value is for the X and then the second value is for the Y. So sometimes learners, they confuse these values. You find that he has taken the formula correctly and wrote it down, but when it comes to substitution, in the X values you find the learner substituting the Y values, and in the Y values you find the learner substituting with X values. So it's very important for you to know that the first value goes for X, the second value goes for Y. So here I said let us take B to be our second point. So the coordinates of B are -2 and -3. So -2 is for X. Then in this case we will say -2 minus. Then what is the X in the A coordinate? The X there is 2, so it means it's -2 minus 2, because this 2 here is positive. And then we say square. Then we say plus, open bracket. Because we have used B as the second point, even in Y, that is what we are going to do. So we'll take -3 as our second point, minus, in this first point, Y is positive again. So we'll say minus Y squared. And then that is what we are having. So when we have it like that, now we do have our substitution. So we have substituted correctly into the correct formula for calculating the distance there. Then now when we have substituted in the marking, like when this it's marked, the substitution into the correct substitution into the correct formula it's always giving you a mark. Then now we start calculating. This is the negative and this is the negative. Then negative 2 minus 2, it's the negative 4 squared. Plus, in this one also is the negative 4 squared. Then, when we have it like that, we are now saying the negative 4 squared. Like, okay, the negative is within the bracket. So it's the same as saying here, negative 4 times negative 4, which will give us positive 16 plus. Even in this case, it's the same story. Negative 4 times negative 4, which is 16. And then in this case, we are having 32. But 32 can also be, if sometimes in other question where they will say simplify this side without the use of a calculator. So this 32, we can write it in the multiples of 2 numbers, whereby 1 we can use it as like we can write a square number and the other one a non-square number. So here is the same as 16 times 2. And then the square root of 16 is 4. So the final answer here will be 4 square root of 2 units. So that is the distance that we are having of AB. So then that is how we calculate the distance. So when we calculate the distance, it's that simple. So sometimes you find that this thing has only 2 marks. So where are the 2 marks coming from? 1 mark will come from the substitution into the correct formula, and then the other mark will come from the final answer with the right unit. So sometimes they will give you what is like those units. They either give you as millimeters, centimeters, meters, kilometers, or whatever the units that they may decide, the examiners may decide to use. So in this case, we're not given any units, so that's why we are saying it's 4 square root of 2 units. So that is simple how the distance is calculated. So then, out of this again, they may say to you, calculate the midpoint of this of that distance there. Calculate the midpoint. So then we can do it in this way if we have to calculate the midpoint. So calculating the midpoint, calculate the midpoint of AB. So midpoint has its own equation, whereby again we will say capital letter M of AB is equals to x1 plus x2, and then we say y1 plus y2. Then that is what we are having there. So if we have it like that, now what are we going to do? So again we are going to substitute. So if we take again A as our first point and B as our second point, so x1 in this case happened to be 2, and then x2 happened to be negative 2. So it would be plus negative 2, which is negative 2 all over 2. And then now we go for y. The y value at A, it's 1, plus negative 3, which is negative 3 over 2. So the correct substitution into the correct formula will also give you a mark. And then when it gives you that mark, then you have what they want. So now, after that, what do? We just simplify. So 2 minus 2, it's a 0. 0 divided by 2 is 0. And then we come this side. 1 minus 3, it's a negative 2. Negative 2 divided by 2, it's a negative 1. So then those are the coordinates of the midpoint of AB. So this is how basically the midpoint is calculated in all the time. Then that is if you are given the values or the 2 coordinates, and then now you calculate it, you get it like that. So now I want us to take a look at how we can also calculate the equation of that particular straight line. So another question may come and say to you, calculate or determine the equation of AB. The equation of AB. So that's how it may say. Sometimes you may need to use that equation to prove that those two lines are parallel or those two lines are perpendicular. So it may not come straight to say to you, calculate that equation, but you may need it in order to prove that two lines are parallel or two lines are perpendicular to each other, or are not parallel or are not perpendicular. So then, here, if they say to you, determine the gradient of AB. So that gradient, we say, it's a small letter m of AB. Capital letter M, it's for the midpoint. It's a midpoint. Then the small letter m is the gradient. A gradient is a slope of a line in a simple language. So then here, that is where we say change in y over change in x. And then that change in y, again, we can change for now. We say this is the first point, this is the second point, so that we see how these things are working out. So here, we are starting with the y values. So if A is our second point and B is our first point, it means that we will say 1, because the y value at A is 1 minus the y value at B is -3. So we say, we use the brackets there, because this is the negative and the negative. And then again, the x value at A is 2 minus the x value at B, it's also the -2. So in this case, is the negative times negative, so it's 1 plus 3 over 2 plus 2. So 1 plus 3, it's 4, and 2 plus 2 is 4. So again here, you will get a mark for substitution into the correct substitution into the correct formula, and then now 4 divided by 4, it's 1. So that is how the distance, the midpoint, and the equation of a straight line are calculated in analytical geometry. So the geometry, that's how it goes. In most cases, I always make a joke with the grade 12 learners to say what you have learned in grade 1, the 1 plus 1, you also do it in grade 12, which is still relevant in grade 12. And then, like, because here, if you see, we had 1 plus 3. This is the simple primary school math, and also 2 plus 2, which is also the simple primary school math. So then, but learners in grade 12, when they come into this, sometimes maybe because of anxiety and fear and, you know, all those kind of things, and then they struggle, but you find that 1 plus 3, they give you something totally different from what they should have given you, which is 4. And 4 divided by 4, it's equals to. Now, what we can just take a look at, we can take a look at the equation of this line. How do we calculate the equation of that line? And then, but when the question comes, you may find that they've given an equation and they want you to find maybe one of the coordinates or one of the values of the coordinates here. So then, when they say determine the equation, determine the equation of line AB. So here, what we have, normally we have y, it's equals to mx plus c. So what we know, we have those coordinates of A and the coordinates of B. So having those coordinates of A and B, then first and foremost, we need to find the gradient. So, and of which we have just calculated the gradient, and then that gradient we have found it to be equals to 1. So now that we know the gradient, and then we can take one of the coordinates to use it as the x and the y. So in this case, we are having, if we take the A because it's the simpler one, both of the coordinates there are positive. So what is y at A? It's 1 equals to, what is m? It's the one that we calculated, which in this case is going to be 1. And what is x at A is 2. And then c is the one that we don't know. So then here we will have, so for substituting again, that's where you get a mark. Then we have 1 is equals to 2, because 1 times 2 is 2 plus c. So when we transpose the 2, it becomes negative. So 1 minus 2, it's negative 1. So our c is equals to negative 1. So but when we have c, it doesn't mean that now we have, like we are now, we leave it there. We must write it in standard form, whereby the y is not substituted, it's y, it equals to, the m is that one there. So we don't write 1, because 1 times any number is equals to that number. So then we'll have x, and then c is the one that we substitute, which is negative 1. So in this case, we're having y is equals to x minus 1. So that is the equation of that particular line there. So then now we deal with it in that way. So there's another way in which we can calculate that using another formula. So that other formula, it's the one that says y minus y1, it's equals to m into x minus x1. Then that is what we're having. So in this case, the y and the x, we don't substitute, we substitute y1, m and x1. So what are we going to substitute there? We just take any of the coordinates there. So we are having y minus, in a, y it's 1. It's equals to, or maybe let's just use the coordinates of b, so that even when you meet something that it's negative, then you know how to deal with it. So in that, we may say y minus negative 3, it's equals to, m we said it's 1, because we have calculated for it, and then x minus, in this case, are going to be negative 2. So you use those brackets. So here, there are brackets, and then there's also that other bigger bracket for that. So here, we have y plus 3, it's equals to, then we multiply this coefficient into everything in the brackets. So 1 times x, it's x. And then negative times negative is positive. And then 1 times positive 2 is 2. So then, that is what we're having. But we have to leave it in standard form. So we transpose 3. So we are having y, it's equals to x. And then it's positive 2 minus 3, which is negative 1. So that is how the equation of a straight line is dealt with in a way in which at least it will satisfy us. So then it's done just like that. Thank you so much.